In Creo Parametric, you can use a bearing load to simulate the action of a shaft on a hole or cylindrical surface. Let's take a look at how to do this. Here I have a model that I want to analyze. Let's go to Applications and then Simulate to go into Creo Simulate. And taking a look at my model, first thing I usually do is assign a material. Let's go to Material Assignment. And right now it just has the default material that was added in Creo Parametric 7.0. Let's go to the More button, and that'll bring open the materials. Here we get the warning about the new default material in Creo Parametric 7.0. I'm going to go to the Granta library. Let's go to non-ferrous metals, and I am just going to grab this aluminum alloy. Let's add it to the model. Click the OK button. And there it is as the material for the material assignment. Let's click OK. Then after I do the material assignment, usually I do my constraints. Let's simulate that this hole is being constrained. I will go to the Displacement tab, and then let's select one of the cylindrical surfaces, and it automatically grabs both of them. And here we are restraining X, Y, and Z from translation. Note the rotations are free. This is a 3D model. When you have 3D elements, constraining rotations does not matter, does not make any sense. So let's click the OK button. And now let's do our bearing loads. To create a bearing load, you're going to use this icon over here. And when you click on it, here we get the dialog box. You can change the name. You can specify which load set it belongs to. Now I will select one of these cylindrical surfaces that the load will be applied to. And then for defining the force, you can use either components in the X, Y, and Z directions, or direction, vector, and magnitude, or use 2 points to define the vector and specify the magnitude. I'm going to use direction, vector, and magnitude. Right now it's being done with respect to the world coordinate system. You can choose a different coordinate system instead. And if I take a look at the graph down in the bottom right hand corner, I can see the directions for the world coordinate system. Let's say I want it going up and then to the right. Well, let's use a factor of 1 in the X direction and a factor of 1 in the Y direction. For specifying the magnitude, if you don't want to use your model set of units, you can use the drop-down list to change that. Maybe I want to enter my force in pounds force and then enter in a value of 100. Let's talk about what is different about the application of a bearing load compared to either a force moment load or a pressure load. With a force moment load, you're going to specify the direction, vector, and magnitude, or the components, or some points and the magnitude like we have over here, and the force or moment will be applied in the direction that you specify. With a pressure load, the load is always going to be normal to the surfaces. You don't specify the direction. With a bearing load, though, again, we want to simulate the action of a shaft on this cylindrical surface. So it's going to be a bit of slightly different math. It's going to use something called a Hertzian distribution. Let's talk about what that means. And to do that, I'm going to jump over to PTC Mathcad. All right, here I am in Mathcad. Let's say that we have a force acting on a cylindrical surface with a certain diameter and a certain length. The formula for the pressure based on that Hertzian distribution is essentially going to be a cosine function. So it's going to be a peak in the direction that the force is going to be applied, and then it's going to taper off as you change the angle from the direction that the force is applied. Now, here is the other important thing to note about a Hertzian distribution. It's a piecewise continuous function. What that means is that when you apply the load, it's only going to act on half of the cylindrical surface. Think about the direction that the shaft is being pushed in. Well, all the force would be on the forward half of the cylindrical surface. On the back half of the cylindrical surface, there would not be any force. And that's what we're representing here with this function. We have the function for the pressure as a function of the angle, and here's the cosine function. But in order to represent how there's going to be no pressure or force on the back half of the cylindrical surface, I'm using this piecewise continuous function with the if statement. If theta is greater than or equal to negative pi over 2 or negative 90 degrees, and this is a logical and operator, if the theta angle is less than or equal to 90 degrees, pi over 2 in terms of radians, then the pressure is going to be applied. If this condition is not true, then the force is going to be 0. And so that's what we have over here. Again, here we have the direction that the force is being applied. It tapers off towards the side, and then on the back half of the cylindrical surface, the force is going to be 0. Let's jump back over to Creo Parametric to take a look at that. All right, so again, we have specified our direction and our magnitude. If I click on the preview button, here you can see the little vector showing it's essentially going off at 45 degrees. That is going to be the peak value, and then it tapers off so that it's only applying on this half of the cylinder. The back half of the cylinder is not getting any load. And then I can click the OK button, and in that way we have defined our bearing load. You'll notice even the graphics in the computer screen show that it's only acting on half of the cylindrical surface. Let's create one more bearing load on the other hole. We will choose bearing, and again select a cylindrical surface. It automatically grabs both halves of the cylinder in the way that Creo Parametric represents cylindrical surfaces. And this time, instead of using direction, vector, and magnitude, I can use components. And maybe in this case over here, I'm going to specify a value of negative 100. And again, I can change this over here. Instead of doing newtons, I can use what I'm more familiar with, pounds force. And maybe in the X direction, maybe we're going to do a value of negative 50. And then I can hit the preview button, and there you can see the direction that the force is acting. I click the OK button, and that way I've got my two bearing loads defined in the model. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.